In this video, I'm going to demonstrate how to check rational expressions that have been simplified using the calculator. And I'm going to show two very similar methods. The first problem I picked intentionally involving division so that I could show you how to enter fractions. In fractions, when you're the first thing you want to do before you use the calculator, if a numerator or denominator has more than a single number in it, you want to enclose it in parentheses. And so you want to go through the problem with your pencil and put parentheses around any numerator or denominator that is not just a single x or a single digit. And this goes for both the answer and the problem. And I've worked the problem out and have an answer written here. Okay, that denominator had to have a parentheses around the entire denominator. All right, and there's another problem here, and that's that division has two meanings in this problem. And only in fraction problems that involve division, you need to put an additional parentheses around the whole divisor so that the order of operations will be followed correctly, because it's not going to know that that's grouped as a fraction first unless you do that, because we've got multiple division symbols there. All right, so now let's turn our calculator on and we're ready to go. We're going to use the y equal key, and you can see I have the keys we're going to use written on the bottom of the screen here. Let's turn to y equal, and I'm going to clear out what's in there, and I'm going to go and enter this expression that we start with, which is right out of your e-text. I'm going to enter it from the top down and from left to right, so it's kind of going to go like this: down through the divide, and then over here, up here, and then down through here and out. Okay, so from left to right and top to bottom. All right, and let's start with an open parentheses to the x key is next to the alpha key right here. It's the x shortcut, and hit squared. We want to copy it identically to the way it's written: plus 21x plus 40, and close parentheses, then divide, and open parentheses, 3x squared plus 23x minus 8, close parentheses, divided by, open parentheses, this is the big one, and then open another smaller one, 4x squared plus 16x plus 15, close parentheses, divided by, open parentheses, x plus 2, close parentheses, and then close the bigger one. And then we go to y2, and that's where we put our answer. So for y1, we put the original problem, and for y2, we put our answer, entered as we have it written here. Open parentheses, x plus 2, close parentheses, divided by, open parentheses, open another parentheses, 3x minus 1, close parentheses, open parentheses, 2x plus 3, close parentheses, and hit. All right, and then we're ready to use the table feature to check this problem. The first thing we always do when we're checking is to go to table set, and you want to make sure that independent is on ask, and you can, if it happens to be on auto, you can move down here and move it to ask with your arrow, and then hit enter. and then mine was already on ask. And now go to table, which is above the graph key. And if anything's in there, you can hit delete. Now, when you're checking an expression, you have to pick a value for x, and you don't want x ever to equal 0, 1, or 2 because of the special number properties of those numbers. So we're not going to pick 0, 1, or 2, and let's pick 5 for x. You can pick anything. You can pick negative 11. All right. In fact, we'll try a couple of them. All right. And what we want to see is that when we put that value 5 into our original expression, we get the same numerical value as when we put it into our final expression. So these algebraic expressions then are equivalent. So we hit enter, and we see that both the original and the final expressions are equivalent. It doesn't matter what number you use, just don't use 0, 1, or 2. Let's try negative 11. All right, and you get different numbers because when you substitute that for x, you expect different numbers. Okay, so let's review what we just did. We used the y equal key, and we took our original expression and substituted in for y1, and then we took our answer and put it where y2 was. We went to table set and made sure independent was on ask, and then we went to table, which is above graph, and entered values not equal to 0, 1, or 2 into the table to see if the original expression was equal to the final answer. Now, this verifies that you haven't made any mathematical mistakes. You may not have reduced it all the way, but you haven't made any mistakes at this point. Let me again mention about the parentheses. When you're dealing with any fractions, numerators and denominators that have an operation going on in them need a parentheses around the entire denominator and the entire numerator. And when you're dealing with division, the whole fraction also needs a parentheses around it. And this is whether or not it has parentheses in the numerator and denominator. All right, let's look at another way to do this that doesn't use the table feature. Some of my students seem to be more comfortable without using the table feature. This time we have a complex fraction with the variable n in it. Again, the first thing we're going to do is go to all numerators and denominators that have more than just a single digit or letter in them and enclose them in parentheses. All right, so let's go to the first fraction here, put a parentheses around it. The 5, the 3, and the n do not need parentheses. And in the denominator of the denominators, first denominator there, we also need a parentheses. But we also need a parentheses around the entire numerator in the complex fraction and the entire denominator. And without that, this would not be possible to do. And then I'm going to my answer and putting a parentheses around the numerator and denominator there. Okay, and so let's go, and this problem also came from the e-text. This time we're going to not use the table feature. We're going to use the regular feature. Now, if you were doing this by hand, you would decide what your value is, your number is, that you're going to substitute in for the variable to check this. And if you were doing it by hand, you'd probably pick a small number. So I'm going to let n equal 3. And when you're doing it on the regular display, you have to store that as a value of n. And the way you do that is you hit the 3 first, then you hit the store key, and then you hit N. And letters other than X require the use of the alpha key. You hit alpha first, and if you'll look over the keys, starting with the math key here, each key on the calculator, let me get a pencil just a second. Okay. Each key on the calculator has above it a letter, starting with the math, A, B, C, and then on until you get to Z, which is, Z is above the 2. Okay, so if you look and find the N, it appears to be above the log. All right, so we're going to just enter the 3 first, because our first order of business, if you forget to do this, I'll show you how to rewrite the expressions, but this needs to go in before you put your first expression in, because otherwise it'll assign a value of 0 to the numbers. Calculators are usually set to 0 for all the variables. All right, so 3, store, and let's hit alpha and then N, which is log. Okay. Oh, man. Okay. And then let's hit enter. And then, so if I just put an N in alpha, it'll tell me the value of N. Let's suppose I put a Z in. Alpha, Z is over 2. It'll tell me the value of Z, which is 0. Most of the variables have a value of 0. In the testing center, they reset the variables after every they reset the calculators after every use, and they're all set to 0. So you want to be careful about that. That's clear. Now let's enter our original expression, and it's going to attach the value 3 to the variable. So we'll start again at the upper left, open parentheses, 5 divided by, open parentheses, N, which is alpha log, minus 2. Close parentheses, and then move up to the minus 3 divided by N, which is alpha log. Close the big parentheses, divided by, open big parentheses, 6 divided by, open parentheses, N, alpha log, squared, minus 2N, alpha log, close parentheses, plus 2 divided by N, close parentheses. And then you just evaluate it and see what you get. But you probably should look at it first and make sure you've copied right. The big parentheses, the first expression, minus 3 over N, close the big parentheses, divided by big parentheses, 6 over the denominator, plus 2 over N, close the big parentheses. All right, I'm hitting enter. I'm satisfied with that. And then you put your answer in. Open parentheses, N, which is alpha log, plus 3, close parentheses, divided by, open parentheses, N, plus 2, close parentheses. I put an X instead of that. Let me go back and make that an N, alpha log. Okay. And then hit enter. And it didn't come out correctly. Let me check my paper. I think I copied the answer wrong. It should have been N plus 3 over N plus 1, not 2. So let me go back there and change that to a 1. And then put a 1 in my problem. Now, I don't have to retype that whole thing. If I hit second enter, it'll replay the lines before, and I can do it up to 10 times and go back 10 lines. But I just need to go back one line, so I'll hit it once, and I'll go over and make that 2 a 1 and hit enter. And now the original and the final check. So let me go back through this. The first thing you do if you're using this screen instead of the table feature is that you just assign a value to your variable by using the store key. And then you hit 3 store n or 100 store n, whatever you want to use. I would not use a value that obviously made a denominator equal to 0. The value 2 would do that. And then you would put the parentheses around where they're needed in the expression, enter the original expression and hit enter, enter the answer, hit enter, and the numbers should be the same. Alright, and you can there's an advantage to using this method, and the advantage is that you can have more than one variable. You could have n and m, or you could have 5 variables. Just at the very beginning you would use store and store a different value for each variable one at a time, and then enter the original expression and then enter the final expression.